Hi, and welcome to the 11th Science livestream. I'm Andreas. I'm the CEO and co-founder of Elicit. Elicit is an AI research assistant, and here we do research into topics that I don't really know anything about with no preparation, a time limit of 30 minutes, and we'll see how far we get. As usual, this is about learning in public. As usual, I hope not too many people watch this because it's always pretty rough. And we're going to be once again researching a topic that someone suggested in the comments last time. This time it's going to be biomimicry. So how can engineering design mimic biology? For example, spider silk. Can we learn from spider silk? What is already being deployed and what could be deployed that hasn't made it into production yet. As usual, I also want to use this as an opportunity to figure out where Elicit falls short and find ways to improve Elicit. And as usual, you can also suggest topics in the comments and we might research them next time. So let's start the timer and see where it goes. All right, so we want to know, maybe to start, what kind of biomimicry already exists in engineering design. So in fact, that could be a good use case of the list of concepts workflow, because we're trying to find a long list of things and we want to kind of brainstorm them. So examples of biomimicry in engineering design. And then later on, we can go into more detail for any of those examples. So this workflow is going to search the literature for papers related to this topic. It's going to then dig through the text of those papers to find as many examples as possible. At the same time, it will also just prompt the latest language models and see what kind of answers they have ready. And then it's going to take those extracted concepts, it's going to remove duplicates, cluster them together, and provide the final answer. I think I mentioned last time that we are struggling a little bit with the load on Elicit on the back end. You can see how it's a little bit slower than maybe you're used to. I still found a lot of papers pretty quickly and found a bunch of concepts, but the general experience is a little bit slower than we would ideally like. And we're working on that. So usually this workflow starts with the language model generated answers, because those are quickest, whereas the papers take a little bit to parse. But you can see here, Velcro, I think, was generated both by the language model and then we get it from specific references as well. Maybe Velcro is actually one of the most prototypical examples here. These like kind of hook and eye fasteners where the little hooks kind of capture the other side of the tape-like thing that they adhere to. Okay, here we have a long list of examples. Seems, on first glance, seems pretty promising. Let's look through it and see what we get. So we have wind turbine blades designed to mimic the shape of maple seeds. Bullet train nose design inspired by a fish. We have bionic cars that again mimic a fish. So seems like aerodynamics is already a place where biomimicry is pretty important potentially. CO2 capture. Actuators that are similar to human muscles. Yep, again, aerodynamic vehicle design. Self-healing concrete based on lizards. Bird safe glass is actually something I've been thinking about because sometimes birds fly into our glass windows. Water collection, similar to cacti. Roof tiles. Solar panels. Windshields. Adhesives. I guess here this is just a cluster of a bunch of things, which are, maybe this is because some of these are not very concrete or didn't fit into a different category. Tree-inspired bridge designs. Concert halls based on animal hearing mechanisms. Movement of autonomous vehicles and drones based on how fish schools move together. Okay, I think that's actually already a really great start. And now I think I'd like to see if there is a review article on this particular question that helps structure this a bit. So I'll once again say biomimicry in engineering design. But then this time I will run a paper search and I will filter for a reasonably recent review article on this topic, and we'll see what we find. I'm gonna sort by most cited within the results here. Actually, I'm gonna change this query, a review of biomimicry, because I do want to, I think this is a topic that, unlike some biomedical topics where it's like quite clear which articles are reviews and which are not, I think I want to kind of more smoothly filter for articles that could be reviews. Okay. I think those are by topic. So here's industrial design, automobile engineering, and to make that easier to parse, I will add a column that asks which topic does this paper, or which topic or area is biomimetic engineering being applied to in this study. And then I will say, just name the topic in 1 to 2 words. Okay, so we have product design, architecture, multiple areas, automobile engineering, industrial design, mechanical engineering. It's a little bit too long. I think what I'm going to do is now I'll load more papers and then I sort by topic. Okay, building design, biomedical, green energy, industrial design, pretty cool that we can look into each of these topics and then see how biomimicry is being applied here. And also, we're immediately noticing that there is something that we currently can't do in Elicit itself, but should be able to do, which is sort by column. Obviously, it's a easy feature, but right now we still have to use the CSV export, and then we can sort by column outside of Elicit. So originally, when I ran the search, one question I had is there a more general review of this topic that I can read? And one way to go about this is to look at, well, here are a bunch of topic areas. Are there any that are, let's say, kind of multiple topics or more general or something like that? And this one that says multiple areas here could be relevant. It has 0 citations, so I'm not sure. Not sure how much I would trust this paper. But let's take a quick look at it. So what does this talk about? Called here an integrative systematic review, carrying out a search on Web of Science with design and biomimicry for 30 years. Here we have a table of works with 35 or more citations. Biomimetics, lessons from nature, and overview. That seems like it could be pretty interesting. It is from 2009, so it will not include all of the most recent work. But yeah, here we get this is the kind of thing I was trying to get to, and that hopefully a future version of Elicit can automatically produce, which is some sort of taxonomy of different kinds of biomimicry. So here you have bacteria, plants, insects, fish, birds, spider webs, etc. And for each of those, it says like what is the type of thing, what are the functions that we can mimic. So birds like aerodynamic lift, for example. Let's take a look at, so given that this was from, cool picture here as well. Given that this was from 2009, one thing we might want to look at is what was the future then? So when presumably at the time of this review, here, Outlook, it presumably talked about what hasn't been done yet and what can be done in the future. So here, the emerging field, I guess it was an emerging field at the time. Commercial applications are new nanomaterials, devices, processes. It's a bit unclear which of these have already been implemented and which of these haven't. Let's see if we can find out about this using Elicit. I'll say something like, I don't know, future or frontiers in biomimicry. And I'll filter for very recent articles so that we only get articles that have been published in the last 5 years or so. Okay, and then what I'd like to add is which, if any, future applications of biomimicry does this paper mention? Make a list of bullet points, each 1 to 2 words, say NA if none. And for this one, I am going to create a high quality column because this does require reading through the paper and parsing what is being said here. And I'll also load more because okay, I mean, this is not exactly a very concrete list, but there might just take a quick look. Maybe not. So I'm going to edit each few words, name very concrete applications. Okay, ecological design, sustainable technologies, architecture. Yeah, these are still a little bit general. Environmentally friendly products, new treatment methods. Let's see if we can make this even more concrete. No general areas, concrete examples. If this doesn't work, then I think it might be the case that the papers, or at least the abstracts, to the extent that we only have the abstracts, just don't give the detail themselves. But it seems like it's already getting a bit bit more detailed here. So medical prostheses, implants. Okay, I think this is getting a little bit better. So here, just checking quickly that in fact the quotes also support this, but it does seem like they do. Okay, we have enhancements, energy production, regenerative medicine. I think it's similar, drug delivery, molecular forensics, implants, lightweight parts in aerospace. Okay, let's load a few more and see if we can figure out more potential answers to this question. Fabrics, polar bear inspired clothing. So this one is about textiles specifically. I think some of the Velcro, I mean, we have seen Velcro before. I think some of these are not exactly about the future, probably because the papers like talk about present day as well as the future. Actually, let's go back and let's click on some of these to see what the context is. Biomimicry can help with some of these things. Okay, here here we have nowadays biomimicry is used in almost every field. Can help with these things. Yeah, but what I would be interested in is what is going to happen in the future. Although it might be the case that the papers don't per se discuss what the future applications are in as much detail, because it's obviously always much easier to talk about the present day applications than the future. All right, let's zoom out and think about where we're at. We started by generating a long list of examples of biomimicry using the list of concepts workflow. And I think that actually was pretty helpful. I literally had never thought about this topic. And so it was good to get a sense. And even the repetition was like a little bit helpful, because I got a sense of like, oh yeah, Velcro is a thing that people just like to name. And likewise, aerodynamics seems like it's just something that is generally very inspired by biomimicry. Then I try to find out on a papers level, like are there any kind of interesting review papers that talk about biomimicry as a whole. I did look at one, this one, and it was okay, but the main thing we got from this is a reference to this other seminal paper, which we then went to, and we found out that it did have this nice kind of taxonomy of different, here it is, the taxonomy of different kinds of objects from nature and which functions could biomimicry. But it was also good to see kind of the list of topics overall and just get a sense for, okay, if you look at the common papers on biomimicry, what topics are common there. And it's pretty all over. Biomimicry, vehicles, product design, architecture, automobiles. And then most recently, I tried to figure out, are there any kind of concrete future applications? And we got some ideas here. I think my first take here is maybe future applications are better versions of past applications. So even better airplanes, even better Velcros. But it might also be the case that some of the papers just don't discuss the future applications as clearly as they could. Future applications mention of biomimicry mentioned in these papers. Ignore applications that are already widespread today. Let's see if this can help us figure out what the kind of fun new ideas could be. Okay, energy sector innovations. So here we have more, this is the kind of innovation in solar panels, where I think right now, as far as I know, solar panels don't work using photosynthesis in the same way as plants. But if you could make them work that way, that could be an improvement in efficiency. Then in the medical field, it is a bit vague here, but we saw earlier kind of the the recreation of lizard tails, for example. If humans could similarly regrow organs, that would be a cool future application. Sustainable architecture. Yeah, I guess this is about like when you make complex objects, can you make them have certain properties, like make them be very stiff or not stiff, or very lightweight or not very lightweight. It's not, I guess, not the most concrete. Yeah, self-repair would be cool if the jackets and pants you wear are self-repairing. That's definitely a thing that is not happening today and that could be happening in the future. And then robotics. I guess this is specifically maybe about sensors of robotics. I do think it's true that the human eye and generally kind of perceptive organs of different kinds of animals are better than the sensors we can build or we tend to build today. Like the human eye is just very good at noticing even individual photons. And so you can probably learn from how biology builds sensors and build even better sensors as a consequence of that. Okay, these are, I guess, these are some pretty interesting future applications. Maybe while we are playing with chat here, we might also want to go back to the original papers and see if we, so these were that I found. Maybe we can get a good summary of what the most common applications are today. I think we have a sense of that, but it would be good to organize a bit. So what are the most widely applied what are the kind of most common applications of biomimicry today? And again, I kind of kept the full text toggle on because my hope is that some of the papers I selected will in fact contain human written answers to this question that then the chat response can refer to. Okay, so again, here we have the mention of kind of functional objects like and their properties, like how stiff or lightweight can they be. It's again a little bit abstract. Civil engineering. How do you develop passive cooling systems like termite moon mounts? How do they cool themselves? Can concrete be self-healing? Then in cars, we previously saw like aerodynamics as a thing that is bio-inspired. Interesting, bio-inspired optimization algorithms. Architecture, natural light optimization, thermal regulation, prosthetics, implants. I wonder, I mean, here for prosthetics and implants, those obviously have to mimic biology because they are literally trying to replace biology. And then material science, yeah, spider silk we saw a bunch of times earlier. Okay. Is there, let's see, is there any pattern in past versus future applications? I'd say not obviously, because biomimicry is already applied across a wide range of things, and potentially the difference is just how far do you go or how much do you learn. So photosynthesis is probably just a more efficient way of converting solar energy into power than even present day bio-inspired systems in that area. And likewise with robotic sensors, I would guess that there are already some that are, again, in some sense, they have to be bio-inspired because they're trying to do the sort of thing that the human eye or the human ear is trying to do. But they could just work better, or they could more directly mimic how the biological systems work. All right, and we are almost out of time. We have 20 seconds left. I appreciate that the person who suggested this topic in the comments, I hadn't really thought about this topic before, and I don't think I had appreciated how widespread biomimicry seems to be. So that was fun, and we're out of time. There's one other thing that people mentioned in the comments, which is they wanted to know how many credits did you use. So we can go back to our credit history and see how many we used today. So as you see, I do have a lot of credits here. So overall, I guess these are all the runs we did today. So this is 2,000, 5,000. I'd say I used about 7,000 credits. So that's not nothing, but also I think the kind of spending about $6-7 for a research session isn't crazy, and I could have